So in this video, we'll start looking at one of our simplest possible electron configurations that we can look at in terms of these term symbols. Pun unintended there. Okay, so if we have, say, a helium atom, something that has a s2 configuration, right? In helium, it's just 2 electrons in a 1s orbital. So we can represent this as, where we have L equals 0, and also to be complete here, m sub L is also equal to 0. And we have an electron, 1 spin up and 1 spin down electron. Right, so as we saw with our Slater determinants and the Pauli exclusion principle, of course, we can't have 2 spin up electrons in the same orbital because that violates, it's impossible to make an antisymmetric wave function from that. Okay, so the question here then is, what are our quantum numbers, our capital letter quantum numbers? What is L? What is S? And what is J? Right, those are our 3 quantum numbers that we use to define terms here. Okay, so L is equal to, well, we know that our value of L is 0. So if we add together all of our L's, we get L is equal to 0. For S, we have, well, there is one, if we think about the m sub s variable, capital M sub capital S, we know I have a plus a half and a minus a half, and overall that's 0. So capital S must be 0 as well, because the z component is 0. Okay. And so J is also pretty straightforward because it's just L plus S, and so we get J equals 0. And so the term that we give this, so just to, again, a reminder of the term, not terminology, but the notation we use, we have uppercase, not uppercase, superscript 2s plus 1 L J. So using our numbers over here, 2s plus 1 is 1, right, because s is equal to 0. So we get 1, s, 0. And the way we pronounce this is singlet S0. So a 2s2 configuration, no matter what electron, what atom we're looking at, whether it's a helium atom or whether it's something like beryllium or anything as we go down the periodic table, has the singlet S0 configuration. And it turns out that this will be true whenever we have a full orbital, a full or an empty orbital. True for all full orbitals. Again, let me move that down so you can see it. So all full orbitals and all empty orbitals have this singlet S0 term that describes them. And there aren't any other terms, right? You can't switch around the electrons and things like that because according to Pauli exclusion principle, we can't have 2 spin up or 2 spin down electrons in the same orbital. Okay, so that's sort of our simplest possible case, is that all of our electrons are paired, there is no overall angular momentum, and we get a singlet S0 term. So this one's not that exciting. But what happens if we excite one of these s electrons to an excited s state? We'll look at that in the next video.